Hi everyone. I'm going to explain to you what a nitrogen vacancy is. So, we're going to start with a diamond lattice. A diamond lattice you can basically think of as two face-centered cubic lattices right inside of one another. And because we have so many carbons that are so densely packed together, it's a very, very strong, one of the strongest bonding structures we can have in nature. Right here, I have a very basic model of a diamond. We have a carbon in the center, and then three other carbons that are covalently bonded to it around. What we're going to do is remove two of these carbons. Then we're going to end up replacing one of our carbons with a nitrogen. Now, carbon, as you know, has an elemental number of 6. Nitrogen has 7. That means that nitrogen has one more electron than carbon did. So, when nitrogen bonds to the three other carbons around it that we did not replace, it has enough electrons to continue those bonds, and then its excess electrons now live inside of this vacancy. Let's talk a little bit more in depth about what's going on in the actual NV center. So over here we have an energy vat diagram. On the bottom we have our ground state, that's where our energy is lowest, and up here we have an excited state where we have high energy. So our electron will typically sit down at the ground state. We need to excite this electron so it has enough energy to jump up to its excited state. We do that by shining a green laser at it, which sends in this green photon. The energy from the photon excites our electron from the ground state up to the excited state, now that it's filled with all this energy. Once we stop shining this energy on our electron, it gets bored and it has to get up that energy. So it drops back down to the ground state. And as it comes from this excited state to the ground state, it gives up the energy it had in the form of this red photon, this red light. And that red light is what we detect when we use an NV center as a sensor.
So the goal of today's lab is to excite the NV center using a green laser and then collect the red photoluminescence that's emitted from it. We will collect it using a dichroic lens first that goes into a photodetector. This is our experimental setup. Here we have the green laser and here we have the diamond. This is the photodetector that collects the red photoluminescence, and this is a dichroic lens. We have a coil here that generates a magnetic field and a microwave pulse antenna over here. So we're going to turn on the laser and set the current to about 50 milliamps and then switch it to on.
And so there we have the photoluminescence showing up on our photodetector.